Okay, as I told you in a previous video, I'm breaking this up. So I would have finished laws of exponents before I started this, but I don't want to do the hard laws right after doing the other ones. So anyways, today we're going to start factoring up polynomials. The first thing you have to do is factor out the GCF. Is there something common with every term of the polynomial before you even start? So, what's the biggest number that divides into 2 and 1? Well, hopefully you said 1, so there is no common coefficient. But as long as there's a variable, the same variable, it's the lowest power that occurs. So in this case, the GCF, greatest common factor, is 1x squared. So then you write the GCF out front, then you say, what do you multiply x squared by to get 2x to the 6th? And that'd be x to the 4th, minus, what do you multiply x squared by to get x squared? And that would be 1. So, what number goes into 6 and 12, and does it have a common variable? Well, the biggest number that goes into 6 and 12 is 6, and it does not have an x in every term. So 6 times what is 6x to the 7th? That'd be x to the 7th. Minus 6 times what is 12? And that'd be 2. Okay, what's the biggest number goes into 6, 9, and 12? And I think you realize that's 3. And is there an x in every term? Yep, and the lowest power is cube. So that's my GCF. So 3x cubed times what is 6x to the 6th? And that'd be 2x to the 3rd, because when you multiply two things in base, you add the powers, plus 3x cubed times what is 9x to the 5th? And that'd be 2x squared, because, oops, I messed that up. It's 3. 3 times 3 is 9. X cubed times x squared is x to the 5th, because when you multiply two things same base, you add. Plus 3 times 4 is 12, and it already has the x cubed, so we're okay with that. So what's the biggest number that goes into 20 and 40? Well, that would be 20. Does it have a variable in both terms? Yep, x to the 10th. So 20 times 1 is 20. X to the 10th times x to the 10th is x to the 20th. And 20 times what is 40? That's 2. And I already have the x to the 10th. Try these two on your lonesome. And then turn me back on. Okay, so 1, 1, 1. So there's no common coefficient. But x to the 15th, there is an x in every term. So you'd have x to the 35th, because when you multiply two things in base, you add. 15 plus 35 is 50. Minus x to the 15 times x to the 15th, minus uno. Then what number goes into 20, 10, and 5? Well, that's 5, biggest number. And x to the 5th, that's the smallest power. Now, if there's 3 terms here, there better be 3 terms inside. So 5 times 4, and x to the 13th, because when you multiply two things in base, you add, minus 2x to the 5th, minus 1. 1 times 5x to the 5th is 5x to the 5th. Now the next one, difference of squares. They realize there's a pattern that if you have a squared term minus a squared term, it will always factor up into 2 binomials. The sum of what you're squaring times the difference of what you're squaring. Notice x times x is x squared. X minus xy plus xy is 0. Y times minus y is minus y squared. So if I can show I have a square minus a square, you do not need to show this step. But what do you square to get x squared? X. What do you square to get 9? 3. So it's x plus 3, x minus 3. So what do you square? Well, x to get x squared. What do you square to get 16? 4. So it'd be x minus 4, x plus 4. It doesn't matter if you put the plus or minus here or here. One or the other, not both. So this one, what do you square? 5. What do you square? X. So it'd be 5 plus x, 5 minus x. Okay, we're getting a little bit more challenging here. So, when I have a base raised to a power, I multiply. So the question really is, what times 2 is 4? And that's 2. So y to the 5th squared. So it'd be x squared plus y to the 5th. X squared minus y to the 5th. Okay, this one. What do you square? Well, 7 squared is 49. X to the 5th. Minus what do you square? Holy cheese. Y to the 10th. Because remember, base raised to a power raised to another power, you multiply. So it'd be 7x to the 5th plus 9y to the 10th. 7x to the 5th minus 9y to the 10th. Mercy. This one. Oh. What do you square to get 16? 4. What do you square to get x to the 30th? 15. Minus, what do you square to get 15? 25. 5. This would be y. So it'd be 4x to the 15th plus or minus, doesn't matter, just as long as one of them has a plus and one of them has a minus. And 4x to the 15th minus 5y. Ooh, try these two on your own. This one and this one. And then turn me back on. Okay, so this would be 8x to the 20th plus 4. Oh, I'm sorry, plus, I want to change this. Well, no, let's leave it. No, let's change it. I made a little boo-boo. Let's change this to a 9. You're so irritated with me. I'm sorry. So that'd be 3, 8x to the 20th minus 3. Sorry about that. I should have caught it earlier. With the 4, you should factor out GCF, and I don't want to get into that now. So just change it to a 9. Sorry. So this one, what do you square to get 121? 11. X to the 40th. Plus, what do you square to get 1? 1. This would be 11x to the 40th minus 1. Woohoo, sorry about this. If you had 2, okay, you're doing it right. It's just you should factor out GCF first, but we haven't talked about that yet. That's in 2 weeks. 2 weeks, not now. So, sorry, just change it to a 9. It'd be 3 and 3. Sorry. But anyways, hey, that's how you factor out a GCF, and that's how you do difference of squares. We'll finish up the binomials in the next video.